I'm going to be talking about these little pieces of kit. This is what we call a microlog, and this is what we call a microlight, and we use them to take temperature readings. If I start with the microlight, it's pretty much like a USB stick. There we go. What we do with this, we can plug it into the computer and set it to take temperature readings at regular intervals. So every 5 seconds, every 30 seconds, every half an hour, whatever it is you need it to do. You can set it to take 2 weeks of data, 3 weeks if you need it. You set it to start at a certain time and finish at a certain time. So if I just set this one up so that it will just start reading when I switch it on. So there we go. It's saying that it's about 18 degrees in here. This one, it's pretty much the same thing as the microlight, but it takes humidity readings as well. So for some manufacturing processes, that's quite important, or if you need to assess whether you need ventilation in a certain room as well. We normally use them for thermal surveys. So an example would be, say we've got a manufacturing warehouse. They normally have very high ceilings. So you've got an extremely large volume of air that you need to heat. What we find in some places is that you've got blowers at the bottom of the factory. They're just pumping hot air in, and what happens is that hot air rises and sits at the top of the ceiling. So you've got inconsistent temperatures throughout the warehouse, and also your staff are going to be at the bottom working. So you're just pumping hot air that's going up and it's not staying where the employees are and where they need the heat. I've got a good graph for you showing that. So this is one survey that we did at a warehouse. What you see is we put two of the little loggers there, and you see the lower temperature is at the bottom of the warehouse and the higher temperature is at the top of the warehouse. So you can see at the beginning you've got the mixing of air as it comes out of the blower, and then the hot air is just rising and sitting at the top. This is important because one, for some manufacturing processes, the one that we're seeing here was with the drying, so it was drying textiles. They can also do leathers as well. Is also important for food industry as well, because it can affect your product. It's just rising to the top and just sitting there, and at the bottom you've got the colder temperature. So all this is wasted energy, basically. One of the things that you could do to solve that would be install a suspended ceiling. That's not always possible because they need the height in some places, but also you can install mixing fans, so it will push the hot air down to the bottom. So you've got your consistency of temperature in the volume of air that you've got there, and also you're reducing your energy because the hot air is, you're keeping it where you need it to be. You'd have, people normally think of household thermostats. The problem with those is that they're set at a certain place. The advantage of these ones is, I mean, as you can see, so tiny and portable. You can leave them anywhere, put it on a shelf. People won't know it's there, which is good, because if they see a logger, they might be tempted to not put the heating on, so they show that they're wasting it. So yeah, it can just go anywhere. And I mean, you're not going to have, if you're measuring heating in a room with very high ceilings like we were, you're not going to have a temperature logger right at the apex of the roof. I mean, we can hang these pretty much anywhere. We've put them at 7 meters high. That's one of the main issues that we have with this, is how do you put it at 7 meters high? Not always as easy as it may seem. I mean, we've been quite lucky. Try and chuck it and see if it falls where you need it to be. But they're quite tough, so that's quite good as well.